Yeah, please kindly turn off your mute your so that we can have. Hello. Yes. Thank you. So today we are going to discuss about the high voltage systems in the automobile field. So everybody knows that EVs are growing like anything nowadays. So today's subject we are going to cover about the definition of high voltage and also the voltage levels in the electric vehicle, high voltage system components, high voltage cables, and also connectors. Then finally, the voltage protection equipments and tools. So this will be our agenda today to discuss. Then at the end, we can have some question and answer session. So because of this government regulations, a lot of incentives are giving for EV sector and also environmental concern. Then the improving economic standards. So all these three factors affecting the EV population. That's why everybody knows nowadays. So major concerns are environmental concern is there. Government is giving some additional, some incentive scheme, motivation towards EV, e-mobility. And the economic standards are improving. So that's why EV population is increasing. So we have to know the high voltage side of the electrification. In conventional vehicle, like our IC engine type vehicle, everybody know what was the voltage range. So in IC engine, maximum it may go up during the time of charging 14.4 voltage. So the voltage range we can say in between 10 to 15 maximum, and the output is around 2 kilowatts, maximum 2 kilowatts they were handling. But now in EV side, electric vehicle side, you can see in the graph there is various type of electric vehicle available, starting from mild vehicle to the battery electric vehicle, and including the charging stations. They are also handling high voltage. When you go to outside charger like a level 3 chargers, DC chargers, they are handling high voltage. So the voltage range you can see from the graph itself. For the EV side, the voltage level is going up to 800, and the power output, power output is almost 100 kilowatt. So earlier with the IC engine, the maximum electrical watt was handled by electrical system in the IC engine type vehicle is 2 kilowatt. And the voltage range was between 10 and 15. But here it is going up to 800 volt. There are plenty of varieties available like FC, fuel cell vehicles, hybrid electric vehicles, battery electric vehicle, mild hybrid electric vehicle. Mild hybrid electric vehicle is almost similar to our IC engine vehicle, but still some of the mild hybrid vehicle going up to 100 volt or nearly 200 volt, their voltage range. So we have to know what is exactly how we can differentiate high voltage and low voltage. Of course, we know that high voltage is dangerous to the human. So we can give we can define, first of all, we have to define what is high voltage exactly. So let us see what is exactly high voltage. The definition of high voltage. Normally in the automotive industry, high voltage refers the voltage above 60 voltage in DC side. Because within the vehicle, we are dealing with the battery. So batteries are DC power source. So there, if the voltage range of the battery, when we go to two-wheeler sector, that is it's safer side, like because the maximum voltage in two-wheeler side still 48, 52 volts. So if it is going more than 60, then we will categorize them as high voltage. because everybody knows that the electric vehicle need to increase the voltage level or current to improve the performance. Because if we are using low voltage, then it will affect the performance of the EV. Because electric vehicle totally depending on electric energy only. So how we can improve the performance in IC engine when you have higher level, higher type of engines, large capacity engines, like starting from 3-cylinder to 2-cylinder, 4-cylinder, 5-cylinder, even 12-cylinder engines are there. So when you increase the size of the engine or capacity of the engine, we can have better performance in terms of IC engine side. But in EV, if you want to increase the performance, then we need to either increase the voltage or current. But current, we have a limitation. What is the limitation of the current? Current, if you are going more than 250 ampere, then the system, the wiring terminals, which we are using to transfer the current from battery to the power systems. So everywhere we need to provide a high quality and higher capacity terminals, which is not possible. So in automobile, the maximum current can be up to 250 ampere. Because some physical limitations are there. If you want to improve the performance, so the only way, more than if your requirement is high, then we have to increase the voltage. That's why we are going more than 800 now. Some of the vehicle they are planning, some of the manufacturers, they are planning more than 800 volt. So to improve the performance of the vehicle, we have to increase the level of the voltage. That's why we need to learn about what is high voltage and the risk of the high voltage. Okay. So if you go to the electric vehicle, the high voltage cables, that means if it is more than 60 or some model, some two-wheeler, even though the voltage is below 60 also categorized that kind of cables in orange color. So if it is high voltage, that is mandatory, keep that cables in orange color. Now, let us see what is the effect of high voltage in human body. Especially technicians or engineers or R&D people, when they deal with this kind of vehicle, what will be the effect? Normally, the effect of the electric vehicle, high voltage, on human body, we can say there is one is electrocution, another one is burning. So the electric current, normally when it is passing through the human body, the muscles will be, there will be some kind of, it depends upon the amount of electric current and the duration of the current, how long and how much current. So it depends on that. There will be some kind of action happening on our muscle, and the muscle may be when you are coming to contact with the high voltage, the muscles may cause to catch with the cable continuously. You cannot immediately remove your hand from the high voltage sources. So that is because of this action happening with the what is that exactly in the physical side, the nervous system affected, and also the ventricular fibrillation may happen when it is passing through the heart. For example, if you are touching the high voltage with the left hand and right hand, for example, left hand with the negative side and right hand on the positive side, then there will be a chance of fibrillation on your ventriculars, and cardiac arrest possibilities are there. Okay. Another thing, the burning chances, thermal effect. Current flow is causing quickly that body tissues may burn due to the high current flow through the human body. And also chemical effect also there due to electrocution. When the current is passing through the body, some of the cell that their degradation may be due to electrolysis that will affect our cells. And in the later stage, there may be some decoloration or itching. So it may happen after 2-3 days. So these are the issues. These are the effect of electric high voltage with the human body. Now let us bring the high voltage in different vehicle. Which are the components and what are the systems? So let us see one by one. Here I am showing the device. Okay, that components in the vehicle which is affected. The drives and the charging components in various type of EVs. So here I have a 3 category. One is mild hybrid, full hybrid, and fully electric vehicle. That is battery electric vehicle. So when we go to the electric motor side of the mild, Suzuki, Vitara, Suzuki brands are coming with, even Volkswagen having mild hybrid. They are using 48-volt battery. Then the motor may be operating at a 36-volt. And in the medium type of mild hybrid, the operation voltage may be around 120, the motor side. But when we are coming to the full hybrid or plug-in hybrid, the voltage range may be 300 to 400, 250. In EV, it will be 300, up to 600 voltage are there in the motor side. Especially in the sports car, it will be around the 600 volt. So when we are going to the inverter side, same. The operating voltage may go up to 800 voltage, from 420 to 800 in sports car, if it is fully EV. And also in other EVs, it will be around 400 voltage for the inverter and converter. So these are the components inside the vehicle and in an EV, and their operating voltage is up to this level. So while we are dealing with this type of vehicle, we have to be aware about what will be the risk. When we are coming to the voltage converter like DC-DC converter, normally in our mild hybrid lower version, there is no DC-DC converter. But in 48 and medium type, there will be 60 and 200 range of DC-DC converters available. In full hybrid and EV, it will be around 400, 420. And the sports car, that means higher performance EVs using up to 800 volt. So these are the various voltage ranges in different systems inside the electric vehicle. Finally, when we go to the battery side, so normally you know that mild hybrid using 15 volt, that is the maximum range of the operation. During the time of charging only, it may go up to 15 volt. And other mild hybrid and medium type of mild hybrid using 60 and 200. When we are coming to the sports car EV, it can go up to 800 volt. That means they are using a battery pack with the capacity of 800 voltage. So that is categorized as a extra high voltage battery. Some subcomponents also there, like a compressor. For operating the AC inside the car, we need a compressor. Most of the EVs, including hybrid vehicle, using electric compressor. So their operating voltage also depends upon the vehicle. It may vary. Normally, EVs starting from 300 volt compressors. But when we are coming to the mild or hybrid vehicle, it can come up to the mild hybrid starting with the 12 voltage, then 36 volt compressor also there, 120 volt compressor, and full hybrid starting with the 300 volt and 250 volt. Also, other components like a heater can vary the voltage, depends upon the type of vehicle. Steering system. Normally, steering system in all model, they are using 12 voltage system only. But in some hybrid, like a mild hybrid with the 48 volt, the steering system operates with the 36 volt. Other vehicles using 12 volt because there is a built-in voltage booster available inside the steering control unit. So these are the drive and the charging system components used and their voltage ranges. Let us see some other like energy transfer components. What are the energy transfer components in the electric vehicle? Like a power distributor, cables, and the connectors, isolating elements, relays, contactor. So these are the various type of um, uh, energy transfer components, and they are also operating at a higher voltage range. Most of the EVs using 400 minimum 400 volt, and in sports higher performance EVs will be around 420 to 800 volt. All the components in the same range. Now let us see the integrated components. Like when we go to the power control unit, there is capacitor, resistor, inductor, relays, fuses, and also many sensors are there, like a current sensor, position sensor. So this capacitor, power semiconductors, even though the voltage level in our mild hybrid is 12 volt, but the semiconductors can work up to 75 voltage in the mild hybrid. When we go to full hybrid, the semiconductors operation range is starting from 650, 650 voltage. And in case of sports car, it can go up to 1200 volt. So that is the voltage level in the power electronic side. Capacitors also same, that they are operating at 440 volt in most of the vehicle maximum. And when we come to the sports car, it can go to 880 volt. In mild hybrid side, it will be lower voltage. Resistors, there are some resistors using inside of like pre-charge resistors for reducing the risk of current flow during the time of switch on. So those resistors also working at the higher voltage level. You can see in the chart. And inductors are there. Many inductors we are using inside the power control unit to boost the voltage. Also, same time when you reduce the voltage to the level of charge battery, that time we are using inductors like a converter, boost converter. They're using inductors. So these inductors also handling higher voltage, maximum 880 voltage in the high-speed electric sports car. Relays, contactor also same. Fuses, most of the vehicle, there will be fuse available to protect the high current flow. So those fuses also handling this much voltage. And when we are coming to the sensor side, you can see the sensors in all vehicle handling low voltage, only 12 voltage, because sensors are directly connected to the computer or the control unit. So the control unit, computer, they are all working in low voltage side. So sensors are always handling or maximum 12 voltage. Now let us see how we can classify the voltage, which up to which level is low voltage, and in high voltage, is there any standard? Of course, we have a standard. Here you can see the standard provided by ISO 6469-3. Based on that only, we have 3 classification for voltage range in the electric vehicle. If the voltage is up to 30 volt in AC, the RMS, if the RMS value of the root mean square value of the voltage in AC we have 2 classification, RMS value and peak value. So RMS value up to 30 is safer voltage. We can say low voltage. So that kind of classification is 1A classification, that is low voltage. ISO standard is 1A, low voltage. And peak voltage in AC can go maximum 42 volt. That is low voltage. If it is 43, that is high voltage. And in case of DC, up to 60, there is low voltage. 61 mean or 60 plus mean it is high voltage. And when we are coming to the category 2, that is high voltage 2, In that case, AC up to 600 voltage, starting from 30 to 600, we categorize as second category high voltage. Second category high voltage, RMS value up to 600. When we go to the peak voltage of the AC, up to 849 peak voltage, consider as high voltage second grade. Okay. And in DC, it is up to 900 volt. So up to 900 volt, it is second high voltage. And we have one more. We are not calling ultra high. Still, it is high voltage only, because in there are some equipments using ultra high, like our locomotive engines. So here in our road transport, our electric vehicle sector, we are classifying into three level: low voltage 1A, high voltage 2, high voltage 3B. This classification provided by the ISO. So 3B high voltage starting from, in case of AC, 600 to 1000, it is 3B RMS value. Peak voltage from 849 to 1414, 1414 is high voltage 3B. And in case of DC, it can go up to 1500 from 900 volt. So this is the classification of, or we can say class of voltages, three classes: low voltage class, high voltage, again, two levels are there. Okay, so that's all about the high voltages. Now let us go to the high voltage systems in the electric vehicle. So now we are going to discuss about the various systems. Okay, we have this much systems like a traction battery pack, DC-DC converter, electric motor, power inverter, charge port, onboard charger, controllers, auxiliary batteries, terminal systems for cooling, transmission. So these are the various systems in the EV. Let us start with the traction battery pack. So here you can see the traction battery pack for BEV, battery electric vehicle, and the small one is the aluminum color. The blue one is battery pack for the electric vehicle, and the aluminum one is battery pack for the hybrid vehicle. So comparatively, the aluminum or the hybrid vehicle battery will be smaller one, but their voltage range depends upon the manufacturer. So these are high voltage components or systems. Even DC-DC converter. Normally, DC-DC converter we are using to charge our 12 voltage system battery or auxiliary battery. So for that, DC-DC converter is necessary. And most of the, even two-wheelers, they are using DC-DC converter. Some vehicle using only DC-DC converter. From that converter directly they are using. But some of them, in the four-wheeler side, DC-DC converter coming with the auxiliary battery. So they can store electricity and it will be available all day. Otherwise, when you turn off the DC-DC converter, the auxiliary system will turn off. The entire vehicle power will be taken. So we need a charger so we can maintain that voltage. Electric motors also classified as high voltage system components. So they are also handling higher voltages. It can go, depends upon the voltage boosting circuit. It can go up to 880, depends upon the type of vehicles. And the power inverter. It is actually converting the DC power from the battery to AC. So that is the major. So when we handle that high voltage battery power, so these devices also working with, that's why they are connected with lot of orange cable. Here in the picture, you can see and a power control unit from Toyota and some other manufacturers. So with inside this converter unit, we have boost converter, DC-DC converter, inverter. Okay. So it also convert the AC current generated during the regenerative braking. That time they will convert that AC into DC. So there is a built-in rectifier available. Lot of diodes are available inside. Lot of IGBTs are available. So IGBTs are used for converting that DC into AC. The diodes are used to convert the DC into AC into DC. Okay. This further used to recharge the batteries, and the generated voltage we can use to recharge the batteries, and the inverter again change that. They will convert, because once you generate electricity from the during the time of regeneration, the voltage level may be high, depends upon the vehicle speed. So that we will reduce that voltage and convert back to DC and then charging the battery. Same like that, we have AC compressor, electric AC compressor. Normally, all kind of EVs, including hybrid vehicle, using nowadays electric compressor, because hybrid vehicle there is an engine available, but still we cannot use the engine power to operate the compressor. Why? Because of the engine operation is limited for sometimes only 60% of the time only that engine will work. 40% time engine may be not working. So that time how we can operate the compressor? That's why there is a built-in motor available inside, and that motor also working at a higher voltage. Okay. The conventional compressor works with the belt driven, which is attached with the engine. So the mechanical power directly transferred to the compressor. But the electric compressor working with electric motor inside. Okay. So three-phase motor, built-in inverter is there. Directly the cable is coming from the battery to the compressor. So this device also, and it's a high voltage device. In an EV, if compressor fail, EV will not run, which is not in case of conventional IC and. So here, if any failure or any short circuit, the entire vehicle will be affected. So that's why we have to maintain the compressors are so sophisticated, and their oil, the AC gas, whatever manufacturers specify that type of specification we have to follow. In case if you are changing the oil, it may affect the insulation resistance. Then finally the high voltage can go to the body. And if there is a leakage of high voltage, of course the vehicle will not move. Normally the high voltage compressors are working within 200 to 400 voltage range. It is too dangerous in case if you are directly touching the terminals when the compressor is working. Same like that, we have a air compressor. But air compressor normally we are using in FC vehicle, fuel cell vehicles, because fuel cell we need to supply oxygen. For that, we are compressing the normal atmospheric air. Okay, so these compressors are also working with a high voltage. So they are also categorized as a high voltage component. The compressor, why it is necessary? Because the it is one of the fuel cell is working with oxygen and hydrogen. One side we are supplying oxygen, one side we are supplying hydrogen. So that oxygen is supplied from the atmospheric air only. So we have to transfer the air at a higher rate, and it must be cooled at a later stage and send it to the fuel cell. The next devices handling high voltage is our onboard chargers. So onboard charger of an EV or onboard charger is used to convert the AC power supply. Most of the level 1, level 2 charging system need an onboard charger. So onboard charger, normally what we are using, what is the purpose of onboard charger? It is used to convert the AC supply directly when we are connecting the vehicle to the wall plug. So AC supply will come to that onboard charger. Okay, and then convert that into DC supply. The onboard charger is located and installed inside the car. It monitors various battery characteristics and control the current flowing inside the battery pack. So that is a function of the, because they will communicate with the BMS. The onboard charger have a communication system like a CAN or any communication protocol they will use to transfer the data from BMS to the onboard charger. So onboard charger knows what is the condition of the battery, then they will regulate the current flow and then charging the battery. So these are the sample. Normally in European standard, it can handle for single phase, it is around 230 volt AC. But in three phase, it can go up to 400 volt AC. So in case of AC, everybody knows that if it is above 30, we categorize them as a high voltage. Okay. And even outside use, some countries using 110 volt single phase as a charging voltage. So that also categorized as a high voltage power supply. Okay. Even charge port, they are also dealing with the high voltage. When we connect during the time of charging, the terminals, if it is a DC charging port, here we are seeing the combined one. Okay, so CCS. Okay, so these type of terminals, in case if there is a failure or faulty relay system inside the vehicle, then there may be possibility of high voltage on this terminal, because they are directly connected to the DC cables are directly connecting from charger to the battery. But the current will flow through some high voltage switching relays are there, like contactors are there. So these contactors are working with the control of BMS or charging control ECU. So they are operating. In case if there is any fault, possible these relays are in on level, then the terminals, but as per the ISO standard that our finger cannot touch with the terminal, the distance they maintain a minimum distance, so it won't be projected from that hole. So even though if you are touching, there may be less chance only to touch the terminals. So these charge port also categorized as high voltage. The charge port connectors the electric vehicle to an external power supply connection. We need a charge port connect. It charges the battery pack. The charge port is sometimes located in the front, or sometimes it is in the rear side of the vehicle, or sideways also available. So these are also high voltage terminals. Next, let us see the cables, high voltage cables. So you can see here this picture showing a hybrid vehicle. The backside is battery located at high voltage battery is located at the backside of the vehicle, and the vehicle is the high voltage cable is transmitted from the battery side to the front side of the vehicle, where we have the engine and power control unit plus transaxle. So these hybrid transaxle carrying motor generator 1 and motor generator 2, both are high voltage component, and also the AC compressor is connected. So from this cable only AC compressor power supply also going. And these wires, these cables from the battery directly going to the power control unit or inverter converter unit. From there, it is distributed to the AC compressor, or if there is any cooler or any pump operated by this unit only, we are supplying. So let us see how this cable is laying under the vehicle or on. So normally, always this high voltage cable connected between battery and the power control unit. No, most of the time it will be under the vehicle. I'm showing here one vehicle underbody. Sorry, you can see the cable laying, orange color high voltage cable. So it never going through inside the vehicle, because that is part of safety. Okay, so there is enough protection available for this cable. Because the cable construction, I will show you the cable construction. Sometimes we are sending cable individually, positive separate, negative separate. Some way manufacturers sending within one pack, both positive and negative will send. So there will be, when you are sending both positive and negative together, there will be extra insulation, protection, everything will be there. I'll show you the layout of the wiring cables, high voltage cables. Here you can see the middle one, that metal part, that is the conductor. Then we have a primary insulation, braided shield, film insulation, outer jacket. See, first of all, we need to protect leakage of high voltage, and also electromagnetic interference level must be within the limitation, within the limit. So we cannot increase the electromagnetic. So for that, and also the protection from flying stone, the cable should not damage with any flying stone during the time of traveling. And so the outer jacket is protecting. So they are made with a strong plastic, vinyl plastics are there. So that is the construction for an individual cable. If it is, we can use it, these type of cable for positive or negative. But there are some cables, some manufacturers using both the positive and negative through one cable. In that case, we have conductor separate. The red one is positive, black one is negative. Then primary insulation. In intersheath mean that is like a rubberized material. So the entire both the cable is protected within that. Then we have and outer jacket, same like a single cable. Outer jacket is protecting from external loads. Here you can see a control system, a hybrid vehicle or EV control system also similar to this. But here I'm showing an hybrid vehicle because we have two motors, MG1 and MG2. See, there are low voltage cables. The high voltage is blinking one in orange and green. You can see that. So that is the only part we are using. So which are the components? MG1 motor generator 1 and 2 inside the transaxle. Then we have inverter and boost converter inside the power control unit. So they are connected, the motors are connected through the inverter, then boost converter, then it is coming to the battery through SMR. SMR means system main release. Also, it is connected to a DC-DC converter to charge our 12-volt battery. Then AC compressor. So only this much devices, we can say around 6 devices connected to high voltage. So remaining all area handling with the low voltage only. So these are the major components connected with the high voltage system. Okay. Now the connectors. Various connectors, high voltage cable connectors are there. So connectors design, connectors construction. We have 3 criteria are there. Like we need sealing. Sealing performance must be good. Superior shield performance, shielding performance. And because that must be covered properly, no chance of leakage of high voltage. Okay, and also superior safety performance. Okay, so while you are removing or connecting or disconnecting time, there may be no chance of touching with the terminal. So like that, we are designing the high voltage terminals, the connectors. You can see various type of connectors. Okay, and their vibration standard, temperature, and withstanding up to what temperature these type of connectors can withstand, and their vibration level up to what level we can. So depends upon the area of application. Like some of the connectors are in the motor side, like a drivetrain. So that area we need to consider higher vibration possibilities. So depends upon the area of application, the design of the connector may change, And the fastening procedure also, maybe we may use some bolt and nut. You can see here in this illustration, the let me take the laser pointer. So you can see this terminal connected with the bolt nut, and there is another one connecting between orange connectors. Okay? So it depends upon the area where we are transmitting the current. Some other connectors like a DC-DC converter. Sometimes we need to splice the 12 volt or 48 volt or even 100 volt, 800 volt. So we need to branch the correct, or from one system we need to connect to two separate systems. Then we need to splice. So splicing cables connectors also, from 2 it may transmit to 4. From 2 it may transfer to another 6. So like that, splicing possibilities are there. So splicing chances we can do with the various type of splice connectors are there. Splicing connectors are there. Now let us go to the high voltage protection systems. So to avoid an accidental touching of high voltage, we have certain procedures. So this is one of the system available in the vehicle. We can remove that service plug. We call service plug. Service plug we can remove to protect technicians or engineers or whoever handling the high voltage system. So they have certain procedure. So this is one of the systems that you have to remove before you proceed with any kind of repair, or when you want to disconnect any cable, high voltage cable, or remove any component. We need to remove this service plug. So where exactly this service plug is connected, you can see here in the battery pack. Here I'm showing a battery pack. See, this is the battery pack. So in this battery pack, the pictorial vision, you can see the various number of modules are there. They are connected in series, and that module in the middle, we have a connection. That middle part, or we can say we are dividing the battery pack into 2 with the help of this service plug. So this is the service plug. In old version, there was a fuse. And now we have only this interlock. Interlock is using only for detecting whether this plug is connected or not, for that sensing purpose. And the fuse is nowadays separately available in the battery pack, and the size of the service plug is reduced because of no fuse integrated. So this service plug will separate the battery into 2 parts. So no output from the battery at that time. Like we are killing the battery. So when you remove, the battery is dead. So they will not provide even a single volt to the output side. So that's why service plugs are there. We can do this function electrically also. When you turn on or turn off the vehicle, there are certain relays available at the end of the battery. Even in the EV, we have switching relays, or we call system main relays. System main relay B, system main relay P, system main relay G. So one will be the ground side, another one for the battery positive side, and in between we have pre-charge. That is for the safety, because when you connect with the system or any load, when you are connecting with that battery, there is a procedure. First we have to turn on the positive, then pre-charge, then the main contactor. Again, the pre-charge will disconnect. So like that, certain some procedure is there. Anyway, this part also use high voltage from the entire vehicle. So that time the power is available only within battery. Okay. That's why these systems voltage, and some precautionary equipments available. So this kind of like a safety shoe, gloves, face mask, goggles, helmet, necessary when you are handling with the high voltage. Additionally, some self-adhesive electrical insulation tape. There may be separate bays are available, but we have to identify the bay by putting some barrier. That's why safety barriers available. High voltage insulated tools are there. and insulated sticks also there. I can show you some application. See now, when we suppose if you don't have tools, highly insulated, we can use the vinyl tape to insulate properly, and then use no issues. But you have to wear safety gloves, high voltage gloves. These are the tools currently available. It can handle up to 10,000, some tools up to 1,000, 10,000, 5,000 volt range. So whenever you disconnect the battery pack, we need to use specified tools only. Do not go with our conventional vehicles, because even one drop down of tool can create a big fire, and it will damage the valuable battery also. So we need to use these type of special tools available for electric and hybrid vehicle. So with that, we are coming to the session, and we can have some question and answer. Shall we? Question and answer, please. Am I audible?
Yes, sir. It is very audible, sir.
Yes, sir. Audible, sir.
Yes, yes.
Sir, good evening, sir.
Good evening.
Sir, my
Good
name is
evening.
Dr. Muruganandam.
Yeah, tell me.
Hello. Yeah, actually, sir, a high voltage battery, when we use a EV vehicle. Hello. Hello.
Yeah, tell me. I'm hearing. Yeah,
Yeah.
tell me.
Yeah. Actually, so is there any chemical equation to generate the heat, sir? Or how the heat is generated maximum levels? So suppose for example, let us take example of hydrogen and oxygen, and like that, the heat is generated normally. When it is generated, sir, how we are going to rectify that? So most of the EV vehicles are explosive, when sometimes it is explosive. So that's what I'm asking for, how we are going to rectify that kind of heat energy, sir.
Okay, our battery, normally batteries are creating these kind of issues. The other area, well protected. In case if you are not properly maintaining your vehicle, there may be a chance of fire from high voltage system. But the issues are nowadays not regular. Some of the issues happen, so they are putting in the media, like Tesla vehicle burn, Ola. So many issues are coming. Even many EV batteries exploded. But that may be due to cheaper BMS, battery management system. Due to the chemical action, nothing will happen. There are different type of battery chemistry available, like lithium-ion battery, NiMH battery. NiMH battery, they are using strong alkaline acid. Acid is there, alkaline is there. So they are dangerous during the time of. So it can make burn only. It will not create fire. A fire chance from lithium, if you are not maintaining the voltage level, and when you are abusing the battery usage, like abnormal current drawn from the battery or abnormal charging, when you are not keeping a good management system. Nowadays, most of the electric vehicle manufacturers focusing more on good BMS, like battery management system. So they are continuously observing the battery charging or discharging process, and it will regulate the current flow. So there is very, very minimum chance only to get fire. These chemical reaction, whatever chemical reaction happening inside the battery is just for transferring the ions, the charged ion from lithium positive terminal to the negative terminal during the time of charging and discharging. So it may go both direction it will happen. And that will not create any fire. When the terminal temperature goes abnormally due to voltage or due to long time use or large current withdrawal, at that time only the fire chances. But now most of the manufacturers got a lot of data from the usage of the electric vehicles, and they are regulating the current flow with effectively with the better management system. Okay.
Yeah, thank you, sir. Thank you. Thank you very much, sir.
Yeah, hello, sir. Yeah,
Yes.
myself, Santosh Dogra. Actually, you have mentioned a point regarding regeneration. So,
Yes.
regeneration regarding means I want to know about that means the type of the motors which are used in EVs, the PMSM or BLDC. So, whether they really do add up in the regeneration, and in that case, how come we take the means the protection is taken against that regeneration voltage? In the case if the batteries are fully charged, so what steps are taken in the EVs in that case?
See, regeneration, any motor, if it is PMS, SM type, permanent magnet synchronous motors, they have built in one side we are using metal conductor, one side magnet. So if you rotate any motor, one side if it is magnet, automatically it will generate current. You know that when we rotate a magnet inside the conductor, it will generate current. So that action we call regeneration. In PMSM, during the time of braking, the motor will change to generator, and that will generate electricity. In normal vehicle, what is happening? The brakes are applying on the rotor disc and converting the kinetic energy accumulated on the vehicle body into heat, and we are losing that energy. But in case of electric vehicle, not all the electric vehicle, like some of the two-wheeler, we don't have this option because it needs some power electronic components. So it is matter of cost. So when you have a motor control unit attached with, equipped with this regeneration module, so you can collect the current generated by the motor and convert that into DC, because when it depends upon the vehicle speed, the generated voltage may be going more than the battery voltage level. So that we have to reduce and convert into DC, then supplying to the battery, so battery will charge. This is the process normally happening during the time of regeneration. But this is not always available in all manufacturers because of the cost involvement. But we have advantage. The regeneration will improve the range of the EV. When you are using regeneration, the additional power generated will improve the range of the vehicle. Okay? That's all. I think you are clear about what is regeneration and how it is happening.
I'm clear about the regeneration. Only thing I was concerning about that, in case if the battery is fully charged, so what protections are to be taken in an EV to avoid any damage to the inverter section or any other power components from this regeneration voltage?
Oh, okay. See, we have two brakes. One is our conventional hydraulic brake and our regeneration brake. So always the battery in EV, in case of hybrid vehicle, the vehicle SOC management is waiting for the regeneration. Sometimes, like while you are coming from hill station to downside. Hello. While you are driving from hill station to down, that time continuously, for example, 5 kilometer range is there. Continuously, you are driving downside, switching to EV. That time, the EV motor will act. The generated electricity from the motor will dissipate with the help of another MG1. MG1 is there. So MG1 will rotate the engine simply like a pump. Engine will not use any fuel at that time. No fuel, no ignition. Just we will waste the electricity generated by the regenerative braking. So that will not send it to the battery. Just they will consume it in the form of, so MG1 will work like motor, MG2 will generate in case EV, in case station. That means your vehicle is trying to regenerate. So that time you will get warning, not able to generate. In some model, they are using power dissipation resistors are there. So they will utilize that power dissipation resistors and all the other electric load will operate and supplying to those loads. So you will feel little bit braking, and the remaining braking who can do will do by the hydraulic brake if necessary. Otherwise, vehicle will go turn off the regeneration. How? We are operating the motor in zero torque mode. We are sending little bit energy from the battery towards the generator. So it will not generate, it will not work like a motor, it won't work like a generator. We call that situation is zero torque. So zero torque operation. It is available in EV, it is available in hybrid vehicle, so that no any damage to the power electro. Otherwise, what you have said, same high voltage may transfer to the battery, and battery is already full, so there may be some chance of fire in the control unit. That won't happen because we have a very good computer to observe the battery. Our BMS always sending the battery SOC level to the power control unit, and the vehicle EV control computer. We knows that I cannot charge the battery, so I have to utilize the generated voltage in some other way. Okay, the other ways they will operate the motor in zero torque, and if necessary, applying the hydraulic brake according to the use as per the necessity. Okay, that's the function available in EV within my knowledge. Yes.
Thank you, sir. Thank you.
Okay, that's
Can we perform dynamic charging, but in wired method, like not wirelessly, as wireless method has very few efficiency? So can we perform?
wireless charger and wired charger. You want to know the difference or how we charge the vehicle? What is your question exactly?
Sir, can we perform dynamic charging, like charging when the vehicle is moving, like on the road, but not wirelessly, but wired? So can we
Yes.
perform that?
Yes, available. Some of the heavy vehicle in some European country, but not always. They have small battery. Small battery mean in the sense that the size of the battery is reduced. So intermittently, these vehicles will touch with the cable on the top, so they can charge. On the road, the cable is dangerous because high voltage. So on the road now only wireless induction charge is available in China. Some countries using on the road charge, that is wireless charger. Induction loss is very high. Magnetic loss is there. Maybe we can say 60% efficiency only charging station. So, but the advantage is that battery, the size of the battery can be very small. That the battery may operate only half kilometer or maximum to 5 kilometer range. So within 5 kilometer, you have to find a charger on the road. So you can use that charge or wireless charging track separately available, because whenever you enter into that track, then you have to pay. The charging will start. Money automatically reduced from your bank. So whenever you use that track, it is connecting directly to the payment portal. That's why people use only little time, then they come out. Same like that on the road, if there is powered available like train, tram, they are using power cable on the top. So in between, you can attach your battery with that power cable. Once it is enough level, then come out from the track. Some specific track only providing, not all the track. So you can select that track, depends upon your battery health. That is available, I think. Some of the country like China, many options are there. Yes.
Okay, sir. Thank you.
Any questions, or shall we wind up? Naveen sir?
Can we use regenerative braking in IC engine vehicles?
IC engine vehicle in hybrid vehicles are using IC engine. So IC engine if there is a motor attached with the wheel, then only we can use the regeneration. Suppose if you are going to attach a motor with the wheel, then the cost you see there is already engine plus motor and you need a battery. So of course we need a little bit bigger battery. Suzuki Vitara using mild hybrid. You can see at the back side they have written smart hybrid. They are using a small battery, lithium ion battery under the driver's seat, and also there is a special generator attached with the engine we call ISG, integrated starter generator. So this will generate electricity when the engine is idle. If you are attaching the same one on the gearbox side, so during the time of braking, you can get that is available. That technology is available. We call mild hybrid or medium hybrid or full hybrid. In that case, you can attach a motor with the drive system. While you are braking, it will charge the battery. So we need a bigger battery and a motor. So when you compare both, the cost will be double. Better we can go for a hybrid version.
Okay, sir. Thank you.
Srikumar, there is one question in the chat box, like why high voltage system is having orange color. Is there any specific reason for this?
Easy visible. The people working on the road everywhere. There are two colors. One is orange because it is easily you can see. Number one, we can see easily. It is an international standard that every manufacturer have to use orange as a color for the high voltage cables. The reason so far I don't have more information. I know and from my knowledge that orange is easy to because if you are providing black, blue, dark blue, brown, sometimes it may be not visible to us. But orange is very easily you can see in even when you open the engine compartment or any area where we don't have much light. This wire color is easily visible. Is it okay? Thank you.
Yes, sir.
Sir, is there any difference between EV and hybrid vehicle?
See, EV is fully powered by battery only. There is no engine power. Hybrid vehicle, we have a engine and the option of EV mode is if you want to drive like an EV, there is full plug-in type hybrid vehicles available. In US, people are going with the full plug-in type because in India also many manufacturers nowadays starting to produce more plug-in type. Plug-in type means the size of the battery will be comparatively wide, but hybrid vehicle near to the trunk, very small area, and plug-in hybrid, the battery will be a little bit bigger one. Maybe we can say double of the full hybrid. And those vehicles, you can use it like EV and hybrid. Hybrid means we need an engine support. If you have a hybrid vehicle, we need fuel. If there is no fuel, the vehicle will not move because they are manipulating the engine power with the support of motor. That's why we are getting 30 km per liter in Vitara. Suzuki Vitara having full hybrid, giving 30 km per liter. Such a huge vehicle. So EV means fully operated by electric power only. So we need a battery only. In hybrid, we have both battery and engine, and the energy from engine is manipulated with the power of battery. I have explained, I think in our previous hybrid session, it was very clearly explained. Hybrid, the engine power can be managed with the help of motor. Okay, because you are providing the 70% of the power from engine, the 30% power can be with the help of motor, and that is manageable because electricity is very easy to control by a computer. Engine can be, but it is not up to the motor. Clear now? Your mobile phone, when you are reaching up to 95, 90 above, the charging process will be very slow because we are using a lithium-ion battery in our mobile phone. That same process happening in our vehicle also, because they will reduce the current when it is reaching. So temperature may be high. We will use cooling system at that time. The BMS will start a cooling system to reduce the temperature. If the battery temperature is going abnormally high, it will turn off the charger. That part is there. It won't allow. We have certain threshold values. So for example, 60 is the threshold value, 60 degrees centigrade. Automatically it will stop. But it won't reach into that level because we have a lot of temperature sensor inside the battery pack. So each zone that the temperature can be detected with the temperature sensor. So the temperature sensor will calculate and send information to the BMS. The BMS will say, okay, now I have to reduce the current to charge this battery because the temperature is reaching to this level. Still, if there is any other problem, due to that problem only temperature is rising, automatically it will stop the charging and it will turn off the battery. We have a system main relays, as I shown in the picture. That system main relays will turn off. This battery will be totally isolated and it will operate the cooler. It will operate the cooler and to reduce the temperature of the battery. Okay.
Hello, sir. What are the different methods for charging the auxiliary battery pack which are used for the run our LV system in our EV?
Pardon, I'm not clear about your question. Tell me what kind of battery?
Sir, lithium-ion battery.
Yes,
or
yes.
lead acid battery which are used for the auxiliary source to run our LV system.
Low voltage system, lithium-ion battery.
Yes, sir. Lithium-ion battery which are used for run the LV system in our EV.
See, we have only one battery pack. From that, there is DC-DC converter that will convert and make it low voltage and then supplying to the battery in case four-wheeler. Otherwise, two-wheeler, directly that low voltage DC-DC converter convert into 12, for example. It will convert into 12 and then we are operating all the entire vehicle is operated with low voltage only. Okay? Even dashboard, computers, everything. As I shown in the picture, there is only few devices, around 6 or 7 devices connected with the high voltage. And that is totally isolated from the vehicle. Okay? So it don't have any connection to the vehicle body. And they are separately isolated, separate path insulation method is there, separate protection system is there, separate high voltage detection circuit is there in case of any leak. Low voltage, there is only one interaction between the lithium battery. So in that area, we have a transformer principle to separate the battery not connected to our low voltage system. So they are transmitting like, pulsated AC signal sending to the DC-DC converter. And the DC-DC converter, there is no direct connection with the lithium-ion battery pack. So we are safe. In case if you are using a circuit board to convert that high voltage into low voltage, there may be a chance of high voltage leakage through that circuit board to our body. So entire body electrical working with the low voltage. That low voltage system is totally isolated with the transformer technique. Okay? Okay. So that is available in every vehicle. They are not directly connected. The DC-DC converter is the part which is interacting with the low voltage and high voltage. So that part we have a better high voltage insulation. But still, with the help of transformer principle, we can transmit the power to low voltage side. It is only coupled with the magnetic flux, not with the metal wires. Clear?
So what is the maximum speed and how many kilometers will travel with that maximum speed with fully charged battery?
Speed range depends upon the battery capacity. So every manufacturer have their own specifications, and the battery chemistry, battery capacity, the battery size, these are all parameters for the range and the speed. So if you are using a motor consuming less current, less voltage, you can have more kilometer, more range. The speed, when you increase the speed, of course, you are drawing more current, so it will affect the range of the vehicle. Speed, you can have any kind of speed, especially Tesla and all. When you are sitting inside Tesla and just put it into the drive mode and press accelerator, you may feel like you are sitting in Ferrari. That much acceleration is there. Because of this motor, they have higher torque in the beginning stage, from zero, high torque. So you will feel that a high torque and high speed you can achieve, but it will affect the range of the vehicle. When you consume more power from the battery, your range will be affected. That's why this question you are asking, what will be the maximum speed mean, depends upon the manufacturer. I cannot specifically give this vehicle will give this much kilometer or this battery pack can give this. See, we need, first of all, when you select a motor for this much wattage, the maximum wattage consumption, then we divide the total battery output what. So that much range you can get. Clear? So
Yeah.
how?
Yes,
Yeah.
yes, clear.
So will it be a feasible solution that in dynamic charging, rather than sending power to the battery, like we directly send it to the motors, so the motors will run on the power received on the road? Can a vehicle run efficiently on that?
Yeah, our railway track, you see, we are using 25,000 voltage and directly sending to the circuit. It won't send directly to the motor. It will be, see, motors are working with the accelerator pedal or the throttle. There is a control with the driver. So motor directly controlled by the vehicle navigation. Who is driving that vehicle? He is having an accelerator pedal or throttle pedal. So the throttle is giving the target speed. Now I need to increase the speed, reduce the speed. So the current, the power source, either through battery or if it is through the directly from the dynamic charging system. So it is not advisable directly connect with the drive system. Why? Because any power source, immediate power requirement cannot be satisfied. Say the power lines may be having higher voltage and higher wattage, at that time it can satisfy. But your battery pack, once you have a battery pack inside the vehicle and your charger is connected to the battery can provide maximum ampere than the supply line. So supply line have limitation. Battery can give maximum ampere because they are connected through the power control unit. And even in fuel cell, we are using battery because of this concern. Fuel cell, they are developing high voltage, 300 voltage from the fuel cell. But we are sending that power to the battery, and then battery is providing the power to the motor. So immediate power requirement, battery is like an accumulator. It is a storage unit. So just assuming you have a water tank and your water tank is filling by a motor, a pump operated by a motor, and it is taking water from the well to the tank. So now when you are consuming, you can open the tap in any level from the tank, but filling is constant. When you fill the water from the well, it is constant. You cannot vary. The level of the supply is not varying. For example, your supply voltage from the line is 230 volt. If your requirement is 600 volt, the battery can provide, because the battery can send the maximum current. The boost circuit will convert that into 600. If it is connected to a line, supply line, how you can draw that much current through the supply line? It won't be possible. That's why charging must be to the battery first, and that battery will provide the power to the motor. So motor can take flexible voltage.
And looking the exposure to enhance your learning and skills in the same domain. So here I would like to introduce our ISIE India products, which will help you enhance your skills So come take a look of a small video about ISIE India courses that helps to enhance learning and gives the opportunities for the placements. Okay, have a look.
Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thanks learners for watching this video patiently. Hope you guys have understood our ISI India products. So any of you wants to enroll in the courses or interested in the course, kindly send us the inquiry through a QR code that displayed on your screen. Thank you.
Learners, if you're interested in joining any of the program of ISI India regarding the electric vehicles, scan our QR code. This QR code is only for the course inquiries, not for the certificate. Certificate link will be shared via mail after 9 p.m. Thank you, learners, for joining our webinar. If you're interested in joining any of the course, so do scan our QR code. A technical counselor will connect with you within 24 hours.